Good evening, guys. Good evening. Am I audible? Is my screen properly visible? Dear participants, can you please confirm? I'm waiting for your response to start with the class. Is my voice audible and clear? Yes, thank you. Thanks for the confirmation. So I hope we can start with today's class, right? So yesterday, are you guys comfortable with the class? We have seen a project which is a machine learning classification project. And today we are going to see about a machine learning regression project. Okay. Can you start, guys, with the machine learning regression project? So tomorrow we'll see the unsupervised learning algorithm along with the project. Okay. Both of it as a combo. So today is day 13 of this data science Naan Mudhalvan virtual internship, and I welcome you all on behalf of pantech elearning. So did you guys completed the assignment which I have given in the day 10? So few people are submitting, so make sure you submit it by today, and today a link will be circulated. So make sure you are updating, okay, your assignment in that link. Okay, just paste a link. Clear? So a link for the assignment 2 updation will be circulated today. So make sure you are updating the assignment 2 there. Clear? So starting with the class, we are going to see about machine learning regression project, and it is Big Mart sales data prediction. Okay, there is something known as Big Mart. This is some kind of commercial unit. Okay, so they sell many kind of products, and we are going to get their sales data and we are going to make predictions for them. Okay, so the predictions we are going to do is the sales. So when you see about sales, the output, it is what it is. If you are seeing about the sales value, it is a categorical feature or continuous feature. The target here, we are going to predict the sales. Okay, so for which product how much sales is coming, so in that trend we are going to predict it. So this is a continuous, and that means it comes under regression project. Okay, so we are going to see about this Big Mart sales data prediction. So the data scientists at Big Mart have collected, okay, their products across 10 cities, and the aim is to build a predictive model. Okay, and using this model they will try to understand if they sell these kind of products, what will be their sales. So if it is increases or decreases, they can predict. Okay, that's what we are going to do. So that's it about the introduction. Can we start like what we have done in the yesterday's class? Can I go into the collab? Can I get thumbs up, guys? Are you guys ready? So this is the problem statement we are having. Okay, and the data set having these kind of details such as the item identifier, item weight, okay, so fact content in it, visibility, okay, in their store, particular area, whether they are keeping it there or not. So the item type to which it is belong to, the MRP rate of it, okay, unique store ID, the year the store which was established, okay, and when you see about the outlet size, location, whether the outlet is grocery store or some kind of supermarket, and the sales, finally the output. This will be the target for us. So we'll load all the necessary libraries, okay, in Pandas, NumPy, Matplotlib, Seaborn, and some of the required SQL libraries. So it's connecting, and I have to load my data set also. I'll upload this Big Mart data. Okay, it's available in Kaggle. You can download it and try to do the same task. Okay. So now it's ran. I'll load the SQL necessary libraries, and then finally the data set I'm loading in this variable data. Okay, so we'll go and inspect the data with data.head. So I hope we can get all the features which they have described earlier: item identifier, item weight, fat content, visibility, item type, okay, all these things. Finally, the item output sales, what is the sales amount, okay, this will be our prediction. So it's a continuous data, okay. So going with the next one, which will be getting the shape of the data set. So we have to understand, right, what is the shape of it. So it's nothing but 8200, like 523 rows and 12 columns totally. Okay, it's somewhat good data set with lot of rows, and we want to check the null values. And sorry guys, I think I have an internet issue here. Is it clear? I got the collab file is just got disconnected because of some internet issues. Am I audible? Is it clear? Now it's connected. I hope it will be fine for you also, guys. So I'll go with isNull.sum, which will get me null value. So before continuing, can you guys please confirm whether am I audible? Are you guys listening? Is my internet stable? So I'm going to check for the null values using data.isNull.sum. Okay. So it seems like these two columns are having null values. So thanks for the confirmation, guys. So the item weight and this outlet size columns are having null values. So you can also get the percentage. How am I convert this into a percentage? For each of this value, you can divide it with the entire shape and multiply by 100. So it is going to give you the percentage. So it seems like 17%, and this is 28% of which one it is? It is a null value. So we have to handle it, and this data set we are having 17 and 28% of missing values in item weight and outlet size column. Okay, so I'll go and get the information about what all the data types present. So there are objects and numerical types. So this object, it is a categorical data, and it is integer or float, it is a numerical data, right? Is it right, guys? So I'm going to separate them and count the shape of it. Okay, using numpy.object, I'm going to find the data types which are in object, which means a categorical data, and those who are in numerical type, I'm going to get and store them here. So this is giving me totally 7 categorical data are there and 5 numerical features are there. I'll go and get this describe. So this will be the entire count, mean and median values respectively. So next step will be data cleaning, because we have null value. Okay, and where are we having, guys? Please remember these two columns, item weight and outlet size. Okay, the item weight column, the weight of the item, and the outlet size, what it is, the outlet size, we'll see. So the size of the store in terms of ground area covered. Okay, so when you see about the outlet size, we are having something like medium or middle or high, all these terms. So we'll analyze this columns first and then decide what we are going to do with this column, how to handle the null value. So we are going to do some simple task for handling the null value. So I'll go and get this columns, and in that item weight, and you can see there are 1400, nearly 1500 null values are there. Okay, so I'll plot it with the help of box plot. And what can you see from this, guys? Tell me, guys, from this box plot, what can you understand? So answer the question whether there are null value present in this. Is there any null value? Can you find? Is there any outlier? Is there any outliers present here? No, right? So from this, what you can understand, there is no outlier, which means this column don't have outlier. So which means you can easily go and take mean value and replace the null values, which will be a better option. Okay? Clear, guys? Why we are doing? If we have outlier, then we have to go for some other tasks like any imputers or any other handling the null value. But here there is no outlier, so we can actually take the mean of that column and fill that with the mean value. Okay, so I'm replacing this item weight null values with mean value. So now if I go and check it, there is no null value. Okay, since the outlier, there is no outlier, we are going into mean replacement. So we have completed this one. Next one will be outlet size. So here there is like 2500, nearly 2400 null values are there. So I'm going to get the value counts to understand what all things present there. It is a categorical data with medium as like maximum value present, small is then we are having high. Since it is the outlet size, okay, it is a categorical column, we are going to input the missing value with the help of mode, which is the most repeating one with medium. Okay, so I am going to replace it with the mode, and now there will be no null values in that column alone. Clear? So now we have successfully imputed the missing values. Now we don't have that problem. Can we go on with exploratory data analysis, guys? Give me thumbs up in chat box. Clear, guys? So next, going with exploratory data analysis. Okay, so I'll go on with the head once again. Okay, item fact content, and there is some irregularity here. Can you find it, guys? This low fat, which has capital N and capital F, okay, and this is also low fat, which is entered in small letters, so it is counting as a different one, and this LF is also a low fat. Okay, this regular and this reg are also same, they both are same, so this is like misinterpreted, so we are just going to replace them. Okay, so I'm going to take this column and replace, okay, this low fat LF and reg with this one. Okay, and setting the in place equal to true, and I'm just storing them as string type. Okay, so if you want this mode mean, okay, so I'll take and show you. So this one, okay, so if I run this one alone, I'll get the mode value of this column, which will be the medium, right? And if I want that value alone, if I go and pass the index as 0, it is going to give me this medium alone, the value actually. Okay, so we need to fill that value alone, right? So that's why we are passing this. Is it clear, guys? Is it clear? So I'm just using the fill NA option, and here whatever you are passing will be stored there. Okay, so I'm just getting that column and getting the mode value. So if I, without passing this, I'll be getting somewhat like a series with index number and the value. So I want that one, so which I'll pass the index as 0. It is going to give me the value exactly as medium. So that will be replaced in all other places. Yes, assignment 2 update link will be circulated soon. Okay, in this today's class it will be circulated, so make sure you are updating it. And so next one, and now just I have replaced these things and converted into string type. And next one is, we are having something known as years established. Can you see it, guys? Where it is? This one, year establishment year, it is 1999, 2009 and so on. Okay, so I just want to subtract them. Okay, so I'll just replace it to 2023 minus X. So now if I go and get the head, okay, I can get a year which will be numerical value of the year of establishment. It is 24. Okay, how much it is subtracted and it is updated. So it will make our tasks a little bit easier. Okay, and next one, we are going to go into the numerical features. So what are the numerical features, guys? Can you find it? This item weight is a numerical feature, item visibility is a numerical feature, item MRP is a numerical feature. Okay, and this output, okay, year establishment. So we'll go and start with this item weight. So I'm going to plot a dist plot. So this is from Seaborn. You can get a KD like plot with histogram, okay, distance plot. And from this, what you can understand, guys, this is item weight and the intensity, and you can find the intensity high here between this 10 to 15. So hence from the above graph, okay, we can observe that we have the item weight from 5 kilogram to 20 kilogram, and we have the maximum value around 12, which will be the middle one, okay, which is around 12.85 mean value of that. So therefore there are like average value is 12.8 kilogram. Okay, that's what the average weight of product, item weight. And next one, item visibility. Okay, so this visibility is like little bit skewed, okay, towards one side. Okay, That's what we can understand from this data. Next, the MRP rate. And from MRP, what you can find? So from the above graph, we can observe that we have good amount of products for 50 MRP, where it is 50. We are having somewhat high. And then when you go for 100 and 200, okay, and then we are going little bit less. When this is going a little bit higher to the MRP rate, then the amount is like the quantity or density is decreasing. When you go for 50 or 100, okay, we have the peak value. So between the range of 100 to 180, we are having much range of products. Okay. And guys, now the assignment to update link is updated in the chat. So make sure you are updating it there. It's mandatory. Make sure you are updating it there. Okay. Please don't miss it. And next one, this item outlet sales. So I'm going to plot it. And this is also skewed. Okay. So we are having some columns which are skewed. We have to handle it later. And next, going into the categorical features. Okay, what are the categorical features? Starting with the item fact content. So I'm just going to give a count plot which will give me a value underscore count. And you can see the low fact is higher count than the regular one. Okay, so the items bought are more of low fat. Okay, when you go for the item type, okay, we are going to give the count plot. And see here guys, every time I'm passing different palette value, it is going to give me different color versions. Okay. So if I set this to set 1, it is going to be in different color, which yesterday I have used, right? You see guys, this is what the palette will do. And from this what you can understand, what is the item which is brought the most and which peak is high. This fruits and vegetable, and then the snack food, then frozen food, then canned food, okay, then dairy products. This seafood is least, okay. The count of products buy by the user, fruits and vegetables are high or largely sold, and snacks also have good sales, right? Both of them are in good sales. So they can focus on this, the company can focus on this one, or they can focus on this one to improve this product selling also. So then the outlet size, I'm going to plot it with the help of count plot. So the outlet they are giving the medium size, okay, which is having the highest value. Okay, this high is very small, less, and the small is in the middle one. Okay, and the outlets are more of medium size, and the location type, if you go and get it. So the location type tier 3 are most, okay, compared with tier 2 or tier 1, this combination will be the most one. And the next outlet type. Okay, so the supermarket type 1 is having a higher amount. If it is a grocery store or supermarket type 2 or supermarket type 3, okay, this is kind of there. They are having many branches, right? So if it is a type 1, they are having much sales. If it is type 2 or it is a grocery store or a supermarket type, then it is not that much efficient. Okay, so next, years established. So based on it, okay, if it is a old one, like obviously if it is old, then it should have high amount of sales, right? So that's what the count this one is telling. If this one started 38 years before and it is having highest count. Is it clear guys till now? Is it clear till now regarding the observations we are seeing with the help of count plot for each of the categorical variables? We have completed with the numerical variables. Is it clear? Can I get thumbs up? Can we continue guys? Yes? Waiting for your response guys. Okay. So next one, the item fat content versus the outlet sales. And what you can see guys from this one, tell me guys. Earlier the item fat content, okay, low fat or regular, low fat is sold most, that's what we have seen. Okay, but when you go for this one, what is happening? When you compare the item outlet sales. So what is item outlet sales? Item outlet sales. Based on the sales value, you are actually comparing with the item fat content. Okay. So the item outlet sales are high for both fat and regular items. It is nearly equal. So regular is having high amount, let's a little bit only. So they are nearly equal only. Okay. So next, item visibility, I'm going to plot it with the item outlet sales. So like comparison of visibility with sales value. And there is some issue with this, guys. So what it is so the value here, okay, item visibility, if it is 0, okay, the item sales is high, which is actually like there is some issue with this one. Okay, if the item is highly visible in your shop, okay, it should sold the most. Okay, but this is like different. Okay, so we are going to handle it. The item visibility has a minimum value of 0. This makes no practical sense. When like the product is being sold the most, the visibility cannot be 0. So we have to consider it and consider it as a missing information and impute it with the mean visibility of the product. Okay, so wherever it is 0, okay, it seems like they have left it and then turned into 0. Some issues with that. So if it is 0, we are going to replace them with the mean value of that column. Okay, and now when you go for visualization, you can see it is just moved towards this side. So now the x-axis is item outlet sales and the visibility will be in y-axis. Okay, so we can see the visibility is not exactly 0, indicating it is rarely purchased by the customer. Okay, next one is item type, and with the item outlet sales we are going to compare them. So with this, what you can understand, guys, from this data, this is the sales value, this is a horizontal plot, and which one sold the most value cost wise? This one, right? Seafoods and starchy foods. So the products available were fruit, veggies and snack food. Okay, that's what we have seen it, right? So most product available, which is fruit, veggies and snack food, and the C it was very less. But here they have the highest sales. Okay, hence the sales can be improved with having stock of product that are more brought by the customers. They can improve this sales by increasing the amount. Next, the item outlet sales versus MRP. Based on the MRP rate, okay, this is what we are getting, and when it is by 200 to 250, that we are getting the most, okay, highest amount, highest outlet sales is high here. Okay, with 200 to 250 dollars, it is having the high sales, and the outlet size is item outlet sales. So the medium and high have maximum, and the small is also not that much less, but it is like somewhat medium with compared with these two. Okay, then outlet location with item sales. Okay, so tier 2 is having the high sales amount. Okay, but tier 1 is the most preferred one, and this is having the highest sales, tier 2. So it is going to be tier 3, and tier 2 is having maximum outlets. So based on the years established, okay, we are getting the count, and it seems like this 38 years and this 19, they are having a strong foundation, and this seems like in this 25th year, which means like when you subtract it, it is going to be, I think, 1998, the year established, they are having some kind of problem, so their sales is like down. There may be some issue in that period of time, they got some issues, so the sales is very less in that period, okay, that established place, and the remaining things, they are a little bit high when you compare those. So it is quite evident that outlet established 35 years before is having good sales margin, and before 22 years, so they couldn't improve that one, 25th. And next, this one. So we are comparing the item type, item outlet sales, okay, and then the hue will be fat content, so based on it. And here location type, item outlet sales, and the hue is outlet type. And with this, the tier 3 location type is having all types of outlet type and has high sales margin. Okay, tier 3 is having high sales margin when you compare the supermarket type 3. When you compare with these, whatever the supermarket type may be, tier 3 is having higher sales. Okay, and what you can analyze from this one, so it is, we can see the same trend in all the places. And next thing will be feature engineering. So that's it guys with the exploratory data analysis. Okay, so we have got some useful information how each one is deciding factor. Okay, so can we start with feature engineering guys? So what is the feature engineering we have to do? I'll go and show you the head. Tell me guys in chat box what is the feature engineering we have to do, and we are going to do something for the skewness of the data. I'll explain you that. Before that, see this data set guys. What we have to do in the pre-processing, what all things we have to do if you want to pass this to a machine learning model. Can I get some response guys? Waiting for your response. What all the things, by visualizing this, what you can understand, what all things? Yes, correct, encoding. One thing is encoding, then what will be the next one? It seems like there is no outlier, so there is no issue with that. Next, when you go with the numerical features, you have to scale it, right? So each thing is in different value set, you have to scale them. Okay. Yes, feature selection you have to do it because there is many columns, you have to decide which are all important to reduce the overweight. Okay. So before going into that, we are going to skew the data for some numerical features. We have seen it is like towards positive or negatively skewed. Okay. And we have to like do something for it. And the thing we are going to do is we are going to correct this data item visibility. Okay, so this item visibility, if I go and get this one, we got some numerical features, right? Wait a minute guys. This one, okay, item visibility. So I'll show you here, so with that you can understand comparatively. Okay, I'll pass it here. So I'm just plotting that column and we can see it is skewed. Okay, so we are going to correct it, and this I haven't told you guys in previous class, so please listen. So how are we going to correct this skewed data? So what you can do is you can take the log value of that feature and replace them with the log value. So what this can do is this log value can convert it into a normal data. So it is not like certain, so you may or may not get a Gaussian data. What is Gaussian data? It is equally distributed, like a bell-shaped curve, not going towards one side. Okay, so there is three things you can do guys. One, you can take the log of that value and you can visualize it. If it is a Gaussian data, you can perform that and continue with that. Or you can take the square root from NumPy. Okay, this is log value, this is square root, this is cube root. So the same values, you can take these values. Okay, if the data you are getting, if it is Gaussian data, you can continue with that, or else you can go for some other ways to handle this skewness. So we'll compare. First I'm going to take the log value of that same item visibility and visualize it. See guys. Okay, so it seems like this is going to that end. It is not a Gaussian or normal distributed data. This is also getting skewed. So I'll go and get the square root. Okay, so this is also not that much efficient. So I'll go and get the cube root. Okay, so this cube root, can you see the difference guys compared with these three? This is towards this side, this is towards the right side, and this one can be a middle value, right? So we are getting somewhat like a Gaussian bell-shaped normal data distribution. So we can go with the cube root. So I'm just going to replace the data item visibility with the cube root on that column. Okay, and next thing, yes guys, the next thing will be encoding the value. Okay, so what we have to encode, we have to encode the item fat content. Okay, so I'll go and get the head dot head. Okay, and what all things we have to encode? The fat content with these values, right? Then the outlet location type, where it is tier 1, tier 2, tier 3, the outlet size, outlet type, and item underscore type. Okay, item type is here, outlet location type is here, outlet type is here. Okay, we are going to encode them. So I am going to do like what I have done in the yesterday's class. I'm creating a for loop. Okay, it is going to encode the value, so it is going to transform it. So once it is, I'm just going to save it, okay, what all things it is transforming in a dictionary with a key and value pair. If it is low fat, it is 0, if it is regular, it is 1. Okay, so like this I'm getting all these things which will be useful when we make a predictive system in there. Next I'll go for the head, and now it is fine, right guys? So there are some unnecessary columns which you can directly pick it up and throw. What all things, guys? First one is this item identifier, because it has nothing to do with the sales value, and then the outlet identifier, that also has nothing to do with the sales value. Okay, these two things we have to eliminate it, and we are having few numerical values which we have to scale it. Okay, so there are some columns that needs to be dropping because that's not necessary. It is going to be item identifier, outlet identifier, and the establishment year. Why, guys? Because instead of establishment year, we have just converted into years established, into like how many years. So we are going to drop these things with axis equal to 1. I'll run this. Okay, now we'll go and get the columns. So now our output will be items outlet sales. Okay, and the X, the remaining things. Okay, I'm just going to select them in X and Y. Okay, so next thing will be X train, X test, Y train, Y test splitting. Okay, I'm just setting the test size and random state. 20% I'm setting for test size. Next thing will be feature scaling, guys. These are the features we are having. Okay, so totally it seems like we are having 9 columns. So before going into scaling it, I'm going to scale them and then select them. Okay, so I'm going to use the minimum maximum scalar for certain values and standard scalar for certain values. So I'll run this, guys. For item weight, okay, I'm using standard scalar. Okay, if your assignment is not reviewed yet, please try to submit once again. Okay, when you have submitted, so it is updated little bit earlier only, many of the assignment got accepted. If you haven't got accepted, you can try to post it again. Okay, and wait, they'll accept it. Once you got updated, you can update it in the assignment update link. So the item weight, okay, that column I'm going to use standard scalar and scale them with the mean value of 0 and the standard deviation of 1. So this is what I'm getting once I scale it. And the item visibility, I'm going to do the same using standard scalar. Okay, and for the item MRP, I'm going to use the minimum maximum scalar to scale them within a value of 0 to 1. Okay, and this is what is happening for item MRP. So we have scaled. So once we scale the value, I'm going to take them for feature selection using mutual information regression. So this is a regression problem, and for that we are having mutual information regressor, right? So I'm just using the select k best. I'm going to get the best 7 features. So I'm fitting the datas and I'm passing it as a filter and getting the support to get the column names actually. So I can print the column names, and it is telling the best 7 features are item weight, item visibility, item type, item MRP, outlet location type, outlet type, and years established. So these are the deciding features we are going to give to the machine learning model. Okay, so I am passing X test. I'm just passing it to the test also, because the column name should be same when we go for the testing purpose, right? Clear, guys? Next thing will be the shape of it. So totally it seems like 6800 is for training. So we are selecting it based on the mutual information regressor. So which I have taught you in few previous classes. What is mutual information? What is the formula behind it? So if you pass this mutual information will give you some value based on the mathematics behind it. So what is the greater value? It is going to select. What is the first best 7? It is going to select that. And if you pass this with that, okay, the object dot get support, it is going to give you Boolean values. Okay, I can pass it here. So it will be in the shape of the columns. So this get support will give you a Boolean value which you can use it as a filter. So which means the first column is true, which means it got accepted, and this false means it is not that much important. So I'm just passing it in the xtrain.columns as a filter. So this Boolean can be used as a filter to neglect the false values and getting the true values alone. So these are the accepted one. So I'm just getting that from the xtrain and storing it in xtrain selected. Okay, I'm just passing this alone, the column names alone using as a filter. It is going to give me that data set. I'm just storing these alone in this xtrain selected. Similarly, I'm doing for xtest selected also, same columns. Next thing, we'll be building the model. First, I'm going to use the linear regression. Okay, this is a regression problem. I'm just fitting it and then predicting it. Okay, next we are going into evaluation metrics. First, we are going to do the R-square error. Okay, if the R2 of a model is 0.50, then approximately half of the observation are explained by the model's input. So I'm just selecting from sklearn.metrics. I'm importing R2 underscore score, and this I'm passing the original value and the predicted by the machine value. Okay, I'm running it. So we got around 0.48 for this model. Next, we are going to get mean absolute error and mean squared error. Okay, so the lowest value will be best. So I'm just getting from metrics mean absolute error and mean squared error. I'm passing the true value and predicted value, MAE and MSE. We'll visualize it. So this is what the value you are getting when we pass the mean absolute error and mean squared error. And this RMSE is nothing but root of mean squared error. So we have the mean squared error. If you get the root of it, okay, square root from math, you can get the root mean squared error value. Okay, so we are going into some other model which is nothing but the random forest regressor. Okay, I'm setting some features here. I'm fitting the model and predicting it with xtest value. Okay, so then I'm using the metrics. I'm getting the R2 score and the mean absolute error and mean squared error. This is nearly 0.57. Okay, so this is the mean absolute error and mean squared error, and this value is the root of mean squared error. Previously we got 1259, here it is 1152. Next we are going with XGBoost regressor. Okay, this will be our final model. I'm going to fit the data. Okay, it's fitted, and going for the prediction and calculating the R2 score. It is the same. You have to pass the Y original value and the predicted value. Okay, so this is nearly 0.50, and the mean absolute error, mean squared error, and the root mean squared error. So finally we are going to make a predictive system. Okay, so this is the things which you are having. Okay, the selected things. Okay, xtrain selected dot columns. So I'll run this. So we have to enter some values. What is the item weight? Okay, so I'll just randomly enter some values here. Visibility, okay, so these values are entered now it is reshaped and given to the machine. So the output it is giving us 646. So with this, okay, the company can use it as a predictive system, okay, to find if these are the features, okay, what will be the sales value. Okay, and we have provided some exploratory data analysis for the company for them to analyze and improve in some areas. Okay, clear guys? Is it clear? We have made a predictive system which, if they give some product values, it is going to give them what will be the approximate sales amount they can get from that kind of product combination. So this can help them to increase their sales revenue. Is it clear guys with today's class? So tomorrow we are going to see about unsupervised machine learning, their algorithm and a project for it. Okay, that will be covered in tomorrow's class. And the day after tomorrow's class, now we are using the model and we are training it, right? And actually there are some models which is pre-trained which you can use it for your purpose. So that will be in day after tomorrow's class. And after that we are moving towards deep learning and NLTK, which is nothing but the natural language toolkit or natural language processing. Okay, we'll do some kind of projects with that. Okay, it seems like we are having 1 week left, right? Today is day 13 and day 20 will be the final day. So next Monday will be the last day. Before that we'll try to cover as much as possible efficiently. So that's it guys. Thank you. Thanks for watching, and make sure you are updating the assignment. Okay, today they have circulated the assignment to update link. So if you haven't completed, please make sure you are completing it by today and updating it. Okay. So if you give a request, they will accept it as soon as possible, either today or tomorrow morning. So once your assignment got accepted, okay, please make sure you are updating in that link.